ये पहला प्रॉब्लम आप लोगों का है. दिस इज द फर्स्ट प्रॉब्लम. अगेन आई एम डिस्कसिंग. So first problem is the suppose a system for office automation. So this is for a particular office, okay, for a particular organization. It means this is the small project because dedicated to only office. Okay, automation to be designed. The size for the different modules and overall system for estimated to be. So here the size of different attributes are given: data entry, data update, query, reports. So the nature of the project is, as you told me, that organic type, because this is the small project. So first, you will do the total of the different attributes, that is data entry, data update, query, reports. So it will come 3 KD LOC, and after is different attributes are already given here. These are the different multiplying factors: complexity high 1.15, storage high 1.06, experience low 1.13, programmer capability. So whenever you will go and search the table for the different multiplying factors, you will get in the book this table, and so 15 different multiplying factors you can find there, and there are different values. Now there is no need to remember that table, as I told you earlier even. So here different type of multiplying factors is already given, and in the numerical they will also discuss regarding that remaining attributes or the cost driver attributes had a nominal value. It means it must be equal to 1. Okay, so that whenever you are going to calculate the value of EAF, uh, effort adjustment factor, okay, then you have to multiply all these given multiplying factors. So here 4 multiplying factors are available. MF1 complexity, this is equal to 1.15, 1.06, MF2, MF3 1.13, and MF4 1.17, and rest of the multiplying factors are equal to 1. Okay, as it is already given in the numerical, then you can put the value of is equal to 1 for rest of the multiplying factors. Now, in this numerical, first you have to calculate the total KD-LOC. It will come 3 KD-LOC. Okay. Now you can calculate the EI. It means the first step, as per the COCOMO constructive cost model, uh, you can calculate the EI, means initial effort, and this is equal to A into KD-LOC to the power B. Okay. Now, because the type of the project is organic, then you can choose the values for the constants A and B from the given table. Okay. Now just put the values of A and B, and then you can calculate. Here it is already given in the numerical that all other factors at a nominal rating, means the value for rest of the multiplying factors is equal to 1. Now calculate the initial effort required, total effort required in different phases. So in this case, this is a long numerical. Okay, so effort required in different phases. So those table you have already studied. Then you can also calculate the phase-wise effort and phase-wise duration. Okay, and at the end, the total number of programmers or the person needed. So here, the first you have to write here project type is organic like this. Okay, then calculate the step 1. Okay, so in step 1, as per COCOMO, total KD-LOC it is given 0.6 plus 0.6 plus 0.1, so it will come 3 KD-LOC. Okay, now in step 2, you have to calculate EAF, that is the effort adjustment factor, and EAF is equal to multiplication of the different cost driver attributes. Now in the numerical it is already given MF1 into MF2, MF3, MF4, and so on. Okay, so this is already given 1.15, 1.06, 1.13, 1.17. Okay, these values are this 1.15, 1 this, this. Okay, now here you can calculate EAF, effort adjustment factor. It is already given that it has the nominal rating, so rest of the multiplying factors that will be equal to 1. It will come 1.61. Now the formula for the initial effort estimate, or you can also call the initial effort or sometime initial estimate. So the formula is EI, in capital I is the suffix, EI is equal to A star KD LOC to the power B. Now from the table you can choose the values for the constant A is equal to 3.2, B is equal to 1.05. Because the type of the project is organic, then you can choose directly the values of A and B from the table. Then just put here and calculate with the help of the calculator 3.2 and into, this is the multiplication sign, within bracket 3 total KD LOC. You have already added all these values. Okay. So you will get sometimes, there is no need to add here or to do the summation directly. It may be provided in the numerical or in the problem. Okay. Maybe sometime it will be given as 2 KD LOC or sometimes 31 KD LOC. It will be given directly. Okay. And sometime you can get in such a manner. Okay. Different attributes are this, then you can add all these KDLOC to get the total KDLOC. Okay, so that now you can calculate and choose the value of A and B against the organic type project. Now you can calculate EI, initial effort, means you are getting here value 10.14 PM. PM is the person month. So unit for the initial effort or the final effort is same, PM. You can write person months. Okay. Now next, you can calculate final effort. Okay. Sometime it is called the final effort estimate. Capital E is equal to EAF, effort adjustment factor, into EI. So you know the values of both. EAF you have already calculated with the help of the formula, and you got 1.67 into 10.14. This is the value of EI. Now you can see here, you have already calculated EI, this 10.14. Now you can put and multiply these two. So it will come 16.3 PM person month. Okay. So this is the final effort. Okay. Final effort estimate. Now you want to calculate the phase wise value. So the percentage for the different phases. I told you earlier. So in the table, in the table of the phase wise distribution of effort. So there are 4 phases. Okay, it was given there in the table: system, oblique product design, detailed design, code and unit test, integration test. So uh, there are 4 different phases, and for each phase you can calculate. So first in the table you can see system or product design. So the column of the here, second column, you can choose the values from the second column, because in the first column the KD LOC must be less than or equal to 2 KD LOC. Okay, or in the second column it was given that less than or equal to 8 KD LOC. So you will choose from the second column. So the value under the organic system and less equal to 8 KD-LOC. So you can choose the second column value, and it is equal to 16264216. Okay, because you are going to calculate the phase wise percentage, then 0.16 into 16.3. What is the, that is this is the total effort. Total effort is equal to 16.3. You have already calculated, and just you are opting this value, choosing this value from the given table. Okay, phase wise distribution of effort. So against this phase, it is given in the table 16. The value provided in the table is 16 into 16.3, and because you are taking the percentage, then divided by 100 means 0.16. So it will come 2.6. Again, for the detailed design, second column value in the table provided 0.26 into 16.3. So in the table you got 26, okay, because you are taking the percentage, then uh, it is 0.26, okay, divided by 100 into 16.3. So you will choose the same value again, because you are calculating the phase wise distribution of the effort, then you have to multiply by 16.3 in each case, okay, because this is the total effort and this is the value provided in the table, and divided by 100 means 0.26, 0.42, 0.16. Now you can calculate phase wise distribution of effort. This will come 2.6, again after multiplication 4.2, again 6.8, 2.6. Okay, then you can also calculate, just add all these attributes here, terms phase wise, 2.6 plus 4.2 plus 6.8 plus 2.6, and it will come 16.34. So this is called the final effort estimate. But you have already calculated directly from the formula 16.3. Okay, so this must be approximate equivalent to the final effort. So if you are going to add phase wise, then it must be approximate equal to this 16.3. So there is a little bit difference only due to the some calculation and some floating point problems. You are not getting the exact value, but this is approximately equal 16.3 and 16.34. So this is called the phase bias distribution of effort. Okay. So in this fashion, you can calculate and you can choose the column for the particular values. Okay. From the phase wise distribution of the effort. Now you can, in the next step, you can calculate the project duration. So what is the project duration? The formula is capital D is equal to small c capital E to the power D, where C and D again constant values, and this you can choose from the given table of the duration. Okay, again the uh, against the organic type. Okay, because initially you have already mentioned that the type of the project is organic. So choose the value of C and D from the next table. Okay, the value is fixed for each type of project. Then C and D. So value for the C and D, this is 2.5. Okay. So this is fixed value for all type of project 2.5, 2.5, 2.5. But the value of D is 0.38 and so on for other project. For organic type, this is 0.38. Now put here values. Okay. And choose the values of C and D from the table directly, but you must remember these values of constants for all three type of projects. Okay, because these values for the constants will not be provided in the numerical. So put the value of C and D against the organic type 2.5, and capital is the final effort estimate. Okay, and this you are getting 16.34 from here. Okay, so 16.34 to the power 0.38. So here you will get after calculation 7.23. Okay, because this is the duration, so the unit is month. Okay, capital E is just you have already calculated 16.34. So here you are getting 7.23 months. Now duration for different phases. Again, if you are going to calculate the duration phase wise, okay, then again you have to choose another table, phase wise distribution of the duration. Then one I have already shown you another table for the phase wise distribution of the duration. Then there are three attributes are given, three phases are given: system design, programming, integration. And you have to choose these values from the particular columns as per the total size of the project. Okay. So here the size of the project is 3 kDLOC. It means you have to choose from the second column, because first column is for the size less equal to 2 kd LOC. Second column is for less equal to 8 kd LOC. Third column less equal to 32 kd LOC. Fourth column less equal to how much? 128 kd LOC. Okay, less equal to. So in this case, you will choose second column because here you have the size equal to 3 kd LOC. Okay, so you will choose second column from the phase wise distribution of duration table. Now, as you are going phase wise, it means consider the percentage. Okay, so the value in the second column provided is 19, 63, 18. Okay, and this is the total duration. Likewise, total effort. In the last case, you have already calculated. Now, in this case, whenever you are doing the phase-wise distribution of duration, then complete final duration is 7.23, as you have already calculated in the preceding slide. Now, this is the value you have already chosen from the table. Then 0.19 into 7.23, 0.63 into 7.23, 0.18, 7.23. So it will come 1.37, 4.5, 1.3. This is month. Okay. So this is called the phase-wise distribution of duration. Okay. So this is very easy. Now you can add here total duration 1.37 plus 4.5 plus 1.3, and this is equal to 7.17. So if you will calculate phase wise and then you are going to add all these terms, then you are getting 7.17, and from directly from the formula you are getting 7.23. So this is approximate equal time duration. Okay, so phase bias, if you will add, then you will get approximate same, that is the 7.23. And here, as per phase wise distribution of the duration, then if you will add all these terms, then you will get approximate same values. Okay, 7.17. So this is approximately same. It means if the project will start on 1st June, it will finish in middle of August. You can add all these 7 months. Okay, so if you are going to start on 1st June your project, okay, then you can add these 7 months and then you can calculate that it may be finished uh, in the middle of the August. Okay, so in this way you can calculate all these terms, all these factors. That is the initial effort estimate, or a phase wise distribution of the effort, or final you can say the duration and phase wise distribution of the duration. So in this way, you can calculate all these terms. Okay. So beforehand, you must have the knowledge that how will you judge about the type of the project or the nature of the project, because everything will depend on your experience of choosing the type of project. Okay. So that you can calculate all these terminology accordingly. Now, here the last step for this is the average staff requirement for different phases. Now we have the 3 phases here as per the time duration, system design, programming, integration. Now just we are going to calculate the number of programmers required in each phase. So we can here divide, we have the effort 2.6, and this is the duration. Then if you will divide effort by their duration, then you can calculate the number of persons. Now from where we are getting this 2.6 value? and 1.37. 1.37 it is given here. You have already calculated phase wise. Okay, 1.37. Similarly, you can see here 2. This 2.6. Okay, system or product design. So in first phase, the person month required is 2.6, but the duration for system design or product design, just we have already calculated this, it is coming 1.37. So whenever we will divide 2.6 by 1.37, then we can calculate the 1.9 persons or the programmers required to complete this phase. Okay. Similarly, in case of the programming, we are getting 11. Okay, and this is 4.5. Now we can see here, this is 4.5, and from where we are getting 11. Now you can add these values, detailed design and code and unit test. Because in case of the phase wise distribution of the duration, okay, we have only 3 attributes. Okay, but in case of the, if we are going to calculate the phase wise distribution of effort, then there are 4 phases, 4 attributes there. Okay, then we will add these two. Okay, because in the duration we have 3 only phases or 3 attributes. Then for the second one, we will add this 6.8 and 4.2. So it will come 11, and here the number of, here duration required phase wise for the programming is 4.5. Okay, now here for the programming, just we added 2 terms there, it will come 11 and divided by 4.5. So this will come 2.4%. Now only one attribute is left, that is for integration. And for integration, we have, this is 2.6 divided by 1.3. Okay, then you can see here, here we have 1.3 for the integration, and in this case integration and test, you have the value 2.6. Okay, now 2.6 divided by 1.3, so this will come 2 persons. Okay, now total number of persons here, final effort divided by final duration, 16.3, 7.17. So here you will get 2.2734. It is equivalent to 3 persons. Okay, here you can do the round of the number of programmers or the persons required to complete the project. Now you have already calculated phase wise as well as directly. Okay, so if you have any problem till now, please tell me. Farhan, Asif, Sparsh, any problem till now?
Yes. No, sir. Everything is
No,
clear.
sir.
Okay, so I think you can handle such type of problems easily. Now
Yes,
next,
sir.
next problem, problem number 2. So in this case, just go through this. Software is designed for a simple inventory management system with 4 modules with estimated sizes as follows. So here different number of modules are given, A, B, C, D. So module A 1.5 KLOC. Okay, the same unit, no problem at all. KLOC or KDLOC. Okay, K 1000 D delivered lines of code or sometimes lines of source. Okay, so here in this problem there are 4 modules. Again there is a need arise to add all these modules. Okay, A, B, C, D. So 1.5 plus 1.0 plus 2.5 plus 1.0. Then you can calculate total KDLOC. Okay. Next, you can check here the ratings of the different post drivers are assessed as complexity 1.15, software reliability requirement 1.4, application experience 1.13, programmer capability is 0.86. Okay. Now all other factors have nominal ratings. It means the values for the rest of the multiplying factors is 1 equal to 1 nominal rating. Estimate effort in person month, time required for development, number of persons required. Now no need to calculate the phase wise. Okay, so this is very simple, and you can judge this by your experience here. Tell me the type of project, nature of project, software designed for a simple inventory management. Please, anybody?
Organic, sir.
Yes, you are right. This is organic again, because it is already mentioned, simple inventory management system. Okay, so this will come again, organic type. Now you have to add, you can solve this problem. This is very easy as compared to the first one. No need to calculate phase wise. Okay, everything. So just it is based on the formulas directly, and you have to choose the value of A and B and C and D against the organic type. Okay, so you can calculate in the similar way, in the similar fashion, that is value of EI and then effort adjustment factor. You have to multiply all those multiplying factors. So you can calculate the value of EAF, and EI you can calculate A star KDLOC to the power B. Here total KDLOC is equal to 6. Okay, 1.5 plus 1 plus 2.5 plus 1. So this will come how much? Please tell me. 6 KDLOC. Okay. So you can
Yes, sir.
calculate again, choose the value of, so the same values for the constant A and B, and then put the value of total KDLOC, and then you can calculate easily the value of EI. Okay. And then you have to calculate the value of EAF. Then EAF is equal to 1.15 into 1.4 into 1.13 into 0.6, and rest is into 1. Okay. Other factors have the nominal ratings. Now, after calculating the value of EI and EAF, you can calculate the value of final effort, that is the capital E, and capital E is equal to EAF into EI. You have already calculated the value of EI and EAF, then you can calculate the value of capital E. And after that, what will you do? Please tell me. Time required for development. Okay, you have already calculated the effort, capital E, then time required for development. It means the formula is capital D is equal to C E to the power D. And again, you have to choose the values for the C and D, that is the value of the constants for C and D, okay, from the table, okay, against the value of the organic, we can say the project, okay. Then D is equal to C into E to the power D. Then the value for the C and D, you can choose again the organic project. Okay, so you can calculate the value for the capital here duration, capital D. After that, you can calculate the number of persons required. Okay, the formula is, what is the formula for that? Capital N is equal to capital E divided by capital D. Okay, so you have already calculated the value of the effort, and you have already calculated the value of the capital D. Then capital N is equal to E by D. So here you will get the approximate number of the persons. Then you can do the rounding of that. Okay, so suppose if you are getting the value 2.3 like this, okay, then it is equivalent to 3 persons or 3 programmers, and this is over. Okay. So in this way, you can solve this. And this is the last question. You can understand, just only 1 minute is left. So an operating system is to be developed for multi-user environment. A rough system specification indicates that the size of the product would be 95 KLOC. So here no need to add a different type of attributes. It is already given 95 KLOC or KDLOC. So total KDLOC you have to write equal to 95. Okay. No need to add all those attributes. Here is the total is given. Okay. And after that, the rating of different cost drivers attributes is EAF. You can calculate 1.15 into 1.3 in the similar way. Okay. So first is the, what is the type of the project? Please tell me, anybody. The time is going to finish.
Embedded, sir.
Embedded. How? Please.
Sir, 95 lines.
95 lines. Another? Any
A
other?
rough system, sir.
Multi-user environment. Sir.
Multi-environment. So this is embedded? Or semi-detached?
Yes, sir.
Or semi-detached? An operating system is to be developed for multi-user environment because the lines are not so much, 95 KLOC, and this is you are not going using to use this operating system worldwide. Just you are developing for the multi-user environment.
Yes, sir.